Linacs Technologies.
Hello and welcome to a new Simac tutorial where we use Simac, the Linac simulator, to learn and teach linac troubleshooting, maintenance, and operational procedures. Because of the scatter contribution to the beam dose, the dose measured in a radiotherapy beam will depend on the field size. The larger the field, the higher the dose at the center for the same monitor unit settings. It is usual to calibrate the linear accelerator at a standard beam condition such as a 10 cm by 10 cm field at a depth equal to D max, and then measure the dose difference at different field sizes. These dose differences are called the relative output factors, and in this video, we will simulate how they are measured, and how they depend on the size of both the X and Y jaws. When we pick an operating point and run a measurement, the dose rate is displayed here. Let's go to the Treatment Head tab, and have a look at the treatment head configuration. As you can see, this simulation was run for a 40 cm by 40 cm field. To measure the relative output factors, we need to normalize the dose rate such that the 10 cm by 10 cm field gives us a relative output factor of 1. Let's change the field size to 10 cm by 10 cm and record the dose rate. I will repeat this process for 5, 15, 20, 30, and 40 cm field sizes. Here is the data that we tabulated. It is normalized by the dose rate for the 10 cm field size, and plotted below. Here you can see that for larger field sizes the dose rate exceeds 1, and for smaller field sizes it is lower than 1. This graph shows how the dose rate changes when the field size changes. It can be used to verify monitor unit calculations for static beams, and is often needed as input data for treatment planning systems. Another important metric is the jaw exchange effect, which is demonstrated by measuring the relative output factor for asymmetric field sizes, for both the X and Y jaws. It is measured by leaving one jaw at a fixed position and moving the other. On the second table, the X jaws is fixed at 10 cm, and the field size is changed by moving only the Y jaws for 5, 10, 15, 20, 30, and 40 cm. Similarly, on a third graph, the Y jaws are fixed at 10 cm, and the X jaws moved forming 10 cm by 5, 10, 15, 20, 30, and 40 cm field sizes. At each step the dose rate is recorded. The dose rate versus the field size is also plotted below the table. You can see that the relative output factors are different, depending on which jaw is fixed. This is because the head scatter depends on the height of the jaw. Since the X and Y jaws are at different heights in the head, the amount of head scatter will be a bit different, leading to the jaw exchange effect. So, to summarize, we changed the field size and recorded the relative output factor and demonstrated the jaw exchange effect. Both are very important metrics since they are essential for ensuring accurate dose delivery in radiation therapy. They are used to determine the amount of radiation required to deliver the prescribed dose to the target volume. Measuring the relative output factor is an important part of linear accelerator commissioning. We hope that this video helps to demonstrate the process, and understand some of the peculiar effects, such as why the relative output factor depends on which jaw is changing for asymmetric fields. To get started with Simac, create a free account at Linax.ca. Start your journey to mastering everything about linear accelerators. Thank you for joining this Simac tutorial. See you at the next one. Don't forget, your always free Linax account gets you free Simac runs every day. Go to Linax.ca to get started.